second special triangle, which is a 30, 60, 90, which means this right triangle has angles of 30 degrees, 60 degrees, and 90 degrees. Okay, the unique properties for this are based on the idea or the relationship that if you took two 30, 60, 90 triangles and you place them along their longer legs, what kind of a triangle do we create overall? 60, 60, and 60, which is an equilateral triangle, right? So if we're basing our pattern on the side opposite 30 degrees, this smallest side here. So if this side is 30 degrees, it means in this other triangle, the side of 30, opposite the side of 30 degrees is also an x. What does that mean the whole hypotenuse is going to be, or the length of this entire measure? 2x. So right now we have two pieces from our pattern. We have the side opposite 30 degrees. The shorter leg is x. The hypotenuse, the side opposite the right angle, is 2x. And so in order to find what the pattern is for this other leg, again, we can use Pythagorean theorem this first time just to discover that. So if we take x squared plus b squared, the other side, the sum of the squares of the two sides, bless you, is equal to the square of the hypotenuse, which was given as a length 2x. And so if we simplify what we have here, 2 squared is 4, and x squared, subtract an x squared from both sides. We get b squared is equal to 3x squared. Extract our square root, and we get b is equal to root 3 times root x squared, or if we reorder them, x root 3. Okay, so here is our pattern for the 30, 60, 90 triangle. Okay, so the shorter leg is x, the hypotenuse is 2x, and the longer leg, the side opposite 60 degrees, is x root 3. Okay, so you should be familiar with these patterns. These two patterns, both this one, the one that I have outlined here, as well as the one that I have outlined here, both those patterns, when you're taking your standardized tests, will be included in the reference material. So you don't have to memorize those for the standardized testing. For this class, though, you need to know them. You won't have notes to refer to when you take your final in this class. And so be familiar with those patterns. Okay, so let's take a look at how these patterns apply to different types of 30, 60, 90 triangles. Okay, we'll start with the simplest one. The simplest one is if I give you the shortest leg. Okay, so if you're provided the leg opposite the 30-degree angle, it's a really straightforward pattern. Again, you're looking at x, 2x, and x root 3, and just fill in the pieces. So if we want to find our hypotenuse, we double the leg opposite 30 degrees. So 2 times 2 is 4. And then if we want to find the side opposite 30 degrees, we take this shorter leg and multiply it by root 3. So 2 root 3 fits our pattern. Okay, so for this second example, what would the hypotenuse be? Shorter leg of 3 means hypotenuse is double that 6, and the longer leg is going to be 3 times root 3. Okay, be very careful. The biggest mistake that happens on the 30, 60, 90, and 45, 45, 90 triangles is to mistake the roots. And remember, the 30, 60, 90 is dealing with the root 3 pattern. The 45, 45, 90 is dealing with the root 2 pattern. Okay, so what are some ways that you can remember that? In isosceles triangle, how many sides are the same length? 2. Use the root 2 pattern. In a 30, 60, 90 triangle, what number do you see in it first? 3. Use the root 3 pattern. Okay? So try not to get confused. It's simple mistakes, but they are costly when it comes to quizzes, tests, and finals. All right, so this is as easy as you can get. We increase the difficulty a little bit when we start using radicals for that given side, the shorter leg, but the pattern's still the same. So if we take a side, a 30 degree, the side opposite 30 degrees to be 2 root 3, that means the hypotenuse is going to be double that, or now, is it going to be 4 root 3 or 4 root 6? So if you multiply 2 times 2 root 3, okay, another common mistake that occurs with math students at all levels up to your senior year is lots of students think you distribute through a product, but that's not what you do. You don't multiply this 2 times the 2 and then times the root 3. Okay? When you multiply it, you only combine. You can combine in any order, but those are your factors. So 2 times 2 gives you 4 root 3. If you were thinking that your answer would be 4 root 6, you're thinking of distributing. Distributing only happens through a sum or difference of terms. Okay, so now you would distribute and multiply the 2 times 2. Oops. So that would give you a 4 plus a 2 root 3. Now you're still only going to have the same number of terms that you originally had unless they simplify out. Okay, so here's our hypotenuse is double the length of the side opposite 30 degrees. And then to find the side opposite 60 degrees, we take this given side, 2 root 3, and we multiply by root 3. It still fits that pattern, x, 2x, x root 3. And so when you multiply a radical by itself, it's like you're squaring that radical, and the square and the radical cancel, leaving just the base, 2 times 3, which is 6. The root 3 times root 3? Yeah. So root 3 times root 3, you can think of it 2 ways. You can either think of it, it's the square root of what's 3 times 3? 9. And what is the square root of 9? 3. So you can think of it that way. Or you can think of it, root 3 times root 3 is equivalent to root 3 squared, right? A number times itself is squared. And then here, this square and this radical cancel each other, leaving just the base of 3. All right, now that even works if we're dealing with a radical that isn't a 3 in the radical. So if we have a shorter leg of 3 root 2, the hypotenuse is going to be double that. So 6 root 2. We just double the number in front. And then the side opposite 60 degrees is going to be 3 root 2 times root 3. And so what's that going to give us? 3 root. Combine the product inside the same radical. 2 times 3 is 6. And so that would be our missing leg. All right, questions on this? Again, this is about as easy as it gets, is if you're given the shorter leg. Gets a little bit harder if it has a radical in it. Okay, coming back to the other easy one is if they give you the hypotenuse and it's a rational number. Because what do you have to do to find the side opposite 30 degrees? Again, we're looking at the pattern x, 2x, and x root 3. You're always going to find the shorter leg first. Every other length is based on that measurement. So we're simply going to divide the hypotenuse in half. That's going to give us the length of the side opposite 30. So 12 halves is 6. And then we just take this measure times root 3 to get our other missing leg. So 6 and 6 root 3 are the 2 legs. That works with odd numbers as the hypotenuse as well. So if the hypotenuse is 13, what does the side opposite the 30 degrees have to be? Just in the rational form, 13 halves. And then the side opposite 60 degrees is going to be 13 halves times root 3. 30, 60, 90, you're dealing with the radical 3. Okay. Now, again, it complicates it a little bit more when you're dealing with radicals, but not that much more. We're still going to just divide by 2 to find the shorter leg. So 2 root 3 divided by 2 leaves root 3, and then root 3 is our shorter leg, so what are we going to do to it to find the side opposite 60 degrees? Multiply by root 3, so root 3 times root 3 is 3. Okay, do the same thing even if it doesn't have the root 3 in it. 8 root 5, our leg is going to be half of that. 4 root 5, and then we're going to multiply that by root 3 to get our side opposite 60 degrees. So 4 root 5 times root 3 is root 15, so 4 times root 15. Right, now, if you're getting lost as I'm going through these, which is okay, you wouldn't be the first students for that to happen, what I would encourage you to do is either come and see me, send me an email, or if you're familiar on your own, you can go to Khan Academy. Have you guys heard of Khan Academy? And he does similar things to me, except he's way more long-winded than I am. And it's something that should only take 2 minutes to explain. He usually does it in about 10 minutes. He likes to talk. Okay? But the Khan Academy site has lots of practice problems, and you can just designate to do 30, 60, 90, and 45, 45, 90 triangles until you get it. And so if you want more practice with that, either come talk to me, send me an email, or look it up on your own. It's a very easy to get a lot of these practice problems, and it'll change each time you do it. Kind of like what I do on some of my quizzes and tests. All right, so let's go through the last part. This is the most challenging of the problems working with 30, 60, 90 triangles, and that is you're given the side opposite 60 degrees. Okay, so again, if we look at the pattern, x, 2x, and x root 3, you always need to work to find the shorter leg first. So if you're given the leg opposite 60 degrees and it fits this pattern, again, you can do one of two things. You can either identify that it fits the pattern. This is the pattern x root 3, so x is what? 2. Okay, which means then the hypotenuse is double that, or 4. Okay, the other way that you can do it is you can just directly calculate. So if you wanted to get x root 3 and turn it into x, you have to divide by what? Divide by root 3. So what we could just do is take 2 root 3 divided by root 3, and we get our answer here, 2. So what's 5 root 3 divided by root 3? 5, and then our hypotenuse is double that, or 10. Okay? So again, that's pretty straightforward if it fits the pattern. The difficulty lies when it doesn't fit the pattern. When it doesn't fit the pattern, what you need to identify is dividing by root 3 is very similar to dividing by root 2. There's an alternate form of it, and the alternate form is dividing by 3, multiplying by root 3. Again, this is called rationalizing the denominator. But for right now, as long as you identify this pattern, you should be able to use the pattern. Okay, so if you can't divide by root 3 and come up with a nice, easy, rational number, what you might want to do is divide by 3 and then multiply by root 3. Okay, so if we're given the side opposite 60 degrees as 12, and when we divide that by 3, we get 4 and multiply by root 3 to get our answer. So that fits our pattern. Divide by 3, multiply by root 3. And then to find our hypotenuse, we're just going to take this number and do what with it? Double it times 2. So you get 8 root 3 as your hypotenuse. Okay, so this only works cleanly when you're dealing, with multiples of 3, right? In fact, any multiples of 3, this will work nice and smoothly. So what about 21? What would the length of the leg opposite 30 degrees be if the side opposite 60 degrees is 21? Okay, divide by 3, so 7, multiply by root 3. So you get 7 root 3 as your answer. Your hypotenuse then would be double that, or 14 root 3. Okay, so what about this last example here that fits this same sort of structure or pattern? What's the length of the side opposite 30 degrees? Take 15, divide by 3, which is 5, multiply by root 3. So there's our shorter leg. And then the hypotenuse is going to be double that, or 10 root 3. Now, this same pattern works even if you're dealing with numbers that aren't multiples of 3 or that have other forms. You still just fit the same pattern. So these last two examples, 13, we can't divide by root 3. So let's divide by 3. So 13 thirds and multiply by root 3. There's our answer. It doesn't simplify any further. We leave it in this rational form. Okay, then we can double this to get our hypotenuse. When we double it, we're not doubling all parts of it. We simply double the numerator. So 13, we double that, we get 26. Root 3 over 2 is this value times 2. Oops, over 3. Yeah, thank you. Okay, so we get 26 root 3 over 3 when we double that. Okay, what about this last example? Can we simplify this by dividing by root 3? 3 root 6 divided by root 3 is 3 root 2. 3 root 6 divided by root 3, you get 3 root 2 as your shorter leg. Double that, 6 root 2. Again, you're only doubling the part that's outside that radical. Okay, and so that's your solution.